Hey Zach,
Matthew.
good evening.
Good evening.
How is school going and have you had your spring break already?
Just got off spring break last weekend and school's been going good.
All right. Well, you're in that kind of final stretch here. Spring break's always nice and it's kind of the preview of summer.
Yeah.
So what are we going to look at
So,
tonight?
I just sent you a email
Got
with
it. Got it. Uh,
class.
so so I see a kind of like here's some questions. You have to decide which one you're going to use. Uh, and then another one that I think is a little bit more explicit. It says, why do you use the extracting the square root? Why do you use, or which strategy would you use and
Yeah.
why kind of thing?
That
Yeah.
one, I think what I need, definitely something I want to focus on today is completing the square. And
Okay.
then the quadratic formula. I wouldn't mind going over that a little bit, and then maybe just checking back on a couple of those other things. Probably uh, just a little bit today, and then a little bit, and then probably a lot more next week.
Sure.
Focus
Sure.
on that.
All right. Well, let's just look at number three again. And if you don't have your notes out,
Go
that
ahead.
would be good because then you're not going to like look at them to see how to do this. But let me
Yeah.
share my screen and we'll get started here. Um, Sorry, I shouldn't have snipped all this. And let me just actually write the problem, and
Yeah,
then
that's fine. That's fine.
because you don't actually need to. We'll come back to that. So the instructions would say something like solve by completing the square. Okay, and the approach that you and I have talked about in the past is you get a space there to the right of this where the number usually is, and a space there.
Uh,
And you have to figure out, well, what goes in that space. You do that by manipulating this middle number. Okay, so you take whatever this is, whatever is in front of x, which in this case is -6, and you cut it in half.
so that would be 3.
X minus 3 squared. And then what goes back here is -3 squared.
So then that would be +9.
And you share it in both positions.
So then x minus 3 squared equals 12.
Yes.
And then do I still write 9 in that second row too, or no?
No, no, no. The you've consumed it. It's because 3 plus 9 is 12. Okay.
Mhm.
Now
And then
we're
would I
not.
do square root of that?
Yes, and that's very important here. Is that you're not done. You actually have to like take a square root here. So it's a more involved strategy than just the square root property because you have to. Sorry about that. I'm just trying to get this to get up here. You take the square root of both sides. So on the left side, it becomes just x minus 3. The square root undoes the square.
Uh-huh.
On the right, well, you have to reduce the root.
So would that be like 3.3-ish? Like it doesn't have to be exact, right?
No, well, I'm going to suggest we do it the correct way, which is we come up with the pairs
Okay.
of numbers. Have you seen this before?
I feel like I did in middle school.
Okay. If your instructor isn't emphasizing it, I mean, I don't know what to say. This is necessary. Like if you leave it as the square root of 12, it's correct, but this is better.
So would I write like
But maybe
two?
okay, let's not do that tonight because maybe your instructor isn't emphasizing that, and we're going to go off on a tangent that isn't helpful. So when you
Yeah.
when you solve for x, you're adding 3 to both sides and you put that in front, 3 plus or
Uh,
minus.
I mean, if we were to well, I think you do square root those numbers.
Yeah,
Like
but
if
you wouldn't.
that reduce root thing, would that be like, oh, 12, 2 and 6 square root is that would, or like what makes 6 is 2 and 3. So then when you'd write like 2.3
No,
inside.
No, you would write 2 root 3 instead of root 12.
Okay.
And that's why I said
So,
it sounds like it's out of scope for what you're doing.
all right. Do you think that I will be seeing that soon, do you think?
It's a great question to ask your instructor. Say, hey, Mr. or Mrs. Instructor, I was working on a problem last night. You don't have to say me. I got square root of 12. I remember in middle school or previous class, like I could write it this way. What should
Hmm.
I do in these problems?
Okay.
And see how you're putting it back on them. You're saying hey, I don't really know what to do. How should I proceed? The teacher's your learning guy. They're supposed to tell you, hey, this is the way to go.
All
And,
right.
and I don't know what they'll tell you. So I don't want
Yeah.
to I don't want
Just
to get involved in there. I mean, I have my own opinions, but they're not important because I'm not your teacher
yeah.
because I don't know what they could want here. Okay. Would you like to do another completing the square?
Yeah, I'd like to do a couple of those, please.
Great. So I'm looking for nice problems because nice problems, when you complete the square, give you nice, friendly answers. This one is a setup of a completing the square problem, but it's slightly different than the previous one. Okay. And so actually, let me just make it like the previous one rather than introducing that. Okay. So here's your problem. It would say, hey, solve by completing the square. From the
So,
previous problem, you should create a space between the x term and the equal sign. And the way I'm doing it here, I'm trying to indicate like whatever you put in this position on the left, it's also going to go on the right. It's
all
a
right.
sharing thing, like your brother. Your brother gets a new, well, you get a new car and your brother gets a new car, right?
Uh-huh.
Maybe not.
Yeah, we'll pretend. We'll pretend.
Yeah, but the idea here is the same number has to go on both sides.
All right. So it's like you both get something. Where it's like if you get like your mom gets you a cookie, you have to like give half and half in a way.
Well, so
Or well, not
you
that's
you
probably not
both
necessary.
you both
You
get one.
both get your own cookie.
Yeah. Okay. All right. Now to figure out what number goes there, you take this number that's in front of x and you cut it in half.
So then that would be x minus 6
Okay.
squared
So then the number that goes in this position back here,
is 36
plus 36 plus
plus
36.
36. And
So
then equals, and then would I write 36 or, oh, so I'd write 9 there.
yeah, at some point you have to combine them.
Okay.
You have to say like, okay, I know how to do that. I can add, I can
Yeah.
subtract.
Yeah, this makes a lot more sense compared to I think like maybe 2 months ago we did this or something like that.
Yeah.
And I don't know,
Yeah.
I was pretty confused on it, but now this seems pretty simple.
Okay. So now you're going to take the square root of both sides.
Square root of both sides. Square root x minus 6 squared equals plus minus 9. So then square
And this one's friendly. This one's nice. It's a good number. What is the square root of 9?
3
3. So then you add 6 to both sides. And I think I mentioned this to you before, like it's better to put that 6 in front.
before. Yeah, I
Yes.
was today I was putting the 6 behind on a problem or two, and I was
Yeah.
like, oh wait, I could just put it in front. That made it so much easier.
It helps to, because then you know how to operate between the numbers.
Yeah, 6 minus 3 equals 3. 6 plus 3 equals 9. X equals 9 and 3.
All right. I'm going to give you a problem. I think you're ready to try one on your own.
Yeah, me too.
So take, a few minutes here, whatever you need, but I don't want to start working it out until you've given it a fair shot. It's no different than the last one. It's just different numbers.
Okay, cool. X All right, I got it.
Okay, so I'm gonna work it out here just in case you want to look at it later. Uh, and then you can just check and see if your work is good. It probably is. This one was maybe too similar to the last one. X squared minus 10x, leave a space, equals minus 16, leave a space, x minus 5 squared, plus 25, plus 25, you get 9. So this becomes x minus 5 squared. You take a square root of both sides, plus or minus the square root of 9, plus or minus 3, x minus 5. And then you add 5 to both sides, and you get x equals 5 plus or minus 3. So you should get 5 plus 3, 5 minus 3, so 8 or 2. Does that work? Does that
Yep,
mesh with your
exactly
answers?
what I got.
Fantastic. We should do another one at least. I mean, if you are okay with that.
Yeah.
The there are more obscure problems I can give you, but the I guess we'll just leave it like this. Let me just handwrite this next one here.
Yeah, if I have I
So
think
what
next week I'll know if I'll be doing more like tricky ones and stuff like that.
So what I was trying to indicate earlier is that most of the problems they start out in this form where you actually have to move this number to the other side.
Mm-hmm.
You actually have to add 112 to both sides or
And
whatever
then
that
you
number.
could also solve that in what's it called? Quadratic formula, no, something like that.
So let me answer your question after you do this problem. Let's not get too
Sounds
far away
good.
from what you're doing, but I'm going to fully answer your question. But again, take some time here and see if you can work this out on your own, please.
All right. All right, I think I got it.
All right, so just like the previous problem, I'll work it out here in case you want to look at it later and just compare your steps here. So half of 6 is 3. So it takes on the sign of this. Like if this was minus 6, it would be minus 3. It's plus 6, it becomes plus 3. You square this. This one is always positive, at least for now. We can assume that's true. So 121. Then you take the square root of both sides.
And then that'll give you x plus 3 equals plus minus 11.
Subtract 3. Yep. Again, it's good to write them out, even if you think, oh, I know this, I can do it. Why take a.
It's just always a good thing. And it shows your work.
All right. Okay. So I know you play sports. I know you've been out in the world, right? So here's your home,
Yeah.
and here's some place you want to go. Okay. And before you could drive, you asked your parents for a ride. Okay. You could have walked. Maybe there's a bus near your home. Maybe a bicycle. And now you can drive. Now you can drive yourself. So if we were in a different class and you were doing something, I could say, all right, give me all the possible ways that you could go from your house to somewhere you want to go, and you would give me this list. So instead of this, though, we're going to call This is a quadratic, ax squared plus bx plus c. And we want the solution. We want x equals a number, x equals a number. So instead of this, you could factor. Instead of this, maybe you could use the quadratic formula. Instead of this, you could complete the square.
All right.
Instead of this one, you could, what's another one? You could graph. Okay. So each of these represent a particular way to do this, which is solve a quadratic. Just like the previous example, you still got where you wanted to go. It was just sometimes it was better to ask your parents for a ride.
Yeah, it's like you wouldn't want to go like
if you're getting your mail,
on like a bike.
Yeah, if you're getting your mail, you might as well walk down to get the mailbox, right?
Yeah,
you don't need to ride to, even if you got a long driveway, you should probably have to, do that. And some of these are ridiculous. Like you probably wouldn't take the bus, but you could, right? Like, I mean, these are possible. And so
really tricky.
Yeah, so when you're given a quadratic and you want to find the solution or solve, this is, I guess, solve. Okay, these are like your tools. There's a lot of jokes made in car garages. It's like, you can solve all your problems with a hammer. But sometimes you just need a screwdriver.
Yeah.
So I hope that fully answers what you were asking about.
Yeah, exactly. Like that answered that and like 5 others perfectly.
Sounds good. So what should we do next? What should we go back to that page that was I don't know, I'll say kind of like you got to choose the method that you think will work.
Yeah, I think that's a good, where it's like 5 questions or something like that.
Yes.
All right. And then I do actually have one question left from that.
Of course. Yeah, go for it.
So with all those different strategies, let's say it's like 9x equals 24 or something like that, could you technically use all of those formulas to fix it or no?
Yes.
Or
yes. Like you can always use, like, all of these get you to the same place, just like the list we made, you always got the same place, but
some are just way better than
like imagine you needed to go somewhere and take the bus and you had to like walk to a bus stop and then take the bus and then walk where, like, it's like that would be silly. You wouldn't do that. But so the idea is like certain scenarios make it clear which one you should use. And that's what I want to try to help you figure out is like, well, which one is it? And the problem is that quadratic formula works for everything. I kind of lie. I mean, you can't factor everything. I mean, you kind of can, but you wouldn't. Completing the square works really well when the number here is even. Even.
If not, then it's a whole problem. But
if it's odd, like we're going to look at in letter A, you're going to see like, oh, I probably wouldn't complete the square.
Yeah.
So it's like, and I actually think this is a really important skill, but they don't seem to emphasize this as like identification. It's like, actually, I'm going to rewrite that because it's a little tough to see. X squared plus 7x plus 3. Yeah, you could solve this, but knowing which approach to use is really important here.
Okay, yeah, that answers it really well for me. Thank you. I didn't even know you could do that until now.
Yeah. Well, okay, and the reason is they don't want you to just do one thing. They want to, but anyway, okay. So let's look at some that are very specific that this is not. This is not GCF factoring, and this is not square root strategy. It's not either of these for the moment, and because those are actually very specific ones. So here's what it could be. It could be good old fashioned factoring guess and check. And this is the one you should probably always start with. So you're looking for 2 numbers that multiply to 3 and add up to 7.
So two, so like
So like
I guess
1 times 3,
three,
but what is 1 plus 3?
4.
Okay, so that one's out. I mentioned this just a few moments ago that you complete the square, but it's preferred when this middle number is even. See how the 7 is odd? You'd have to do
Yeah.
7 divided by 2. We don't want to do that.
Uh-huh.
So that one's also out. So the last one that would be reasonable here would be quadratic formula. And you said you want to do, you said you want to do one on that, but this is kind of the approach here. You kind of figure out, well, either you just say it and you say, oh yeah, that's the one, or you go through your list and say, well, that doesn't look so good. So this is the one we want. So quadratic formula, you need A equals, B equals, and C equals. Can you give me those values?
Yeah, A equals 1, B equals 7, C equals 3.
Okay, perfect. If this was minus 7x, how would B change?
It would be -7.
Perfect. Okay, now how well do you know the quadratic formula? Meaning, could you roll out of bed in the morning and say the quadratic formula?
Um, AX squared plus BX plus C
No, no,
equals
no.
0.
This is the quadratic formula.
Oh, I could I could probably I don't know. I'll have to wake up tomorrow and see.
Well, please don't do that. Please don't do that.
Yeah, it's all right. What's up?
But between now and your exam, you likely and someone will ask, someone will say, "Hey, Mr. Instructor, will you be giving us the quadratic formula, or do we have to learn? Do we have to memorize it?" And they're going to say, "You need to memorize."
Yeah, I could definitely get it memorized by then. Like I
Great.
think I have it like more than 50%. It's just
Okay.
like
So what I would suggest is writing it down every time you use it. That will help. Okay.
yeah, that's what I've been doing, and that's it's I don't know, it's really helps. It's kind of crazy.
All right. So the next step is to substitute the numbers in. And you'll notice I'm not writing the square root until after I've substituted the numbers in.
Hmm.
The reason is I don't know how big to make it and
Yeah,
they're long, and it just looks better if I wait until the end.
yeah.
It's a
Keep
little,
it. Okay, so then you'll have minus. Oh right, you have to do the inside
yeah, do
first.
the
So
answer.
that's
49 minus,
12, which is 37. So -7 plus minus square root of 37 over 2
perfect.
would then be.
Now I hope you don't mind this. I've actually really taken to the whole idea of like this being friendly or not friendly. I think it's really helpful for students. I've been using it a bunch since you actually
Oh, really?
told me about it. Yeah, because actually it's very
Cool.
helpful to hear that. This one is not friendly. It doesn't reduce. It's like that's what it is, and you can't make it something that it isn't. So this is your final answer. Now we get to the part where it's like, here is what the instructors actually want. Okay. So like this is the answer right here. You're done. But you need to pretty it up. You need to put it in a form that they like. So the
Yeah.
first thing you do is you actually divide both of these by 2. And again,
So,
like neither of these divide by 2, so it doesn't feel like it's getting any better, but that is what they want.
so then, okay, so I divide both by 2. So I wouldn't solve the top first and then divide it by 2.
You would if this number was friendly.
Okay, so not friendly, divide both.
Yes. Like if it was square root of 36, 6, yeah, you would do exactly what you said, but
Not friendly, divide both. All right, wrote that down.
okay, and in the last part here that I'm showing you here is you just split it apart where one's plus and one is minus.
Okay, so then do I write it as -3.5 plus
No, nope,
18.5, or I
nope.
keep it
No,
just
no,
like
no.
that?
Okay, no, no. Okay, I heard something really bad. The square root is like this impenetrable wall force. Like you can't get to the 37. This
It's
two
like
is
it's like trying to like break steel with like a wooden shovel.
yes, it is
Okay.
impossible to do. Okay. Um, it's if you drive an electric car, as pure electric, you don't get emissions. That's
Yeah.
like it's impossible. That's
Yeah.
like you can't do that because it's not like it. And so what you said, a lot of students misinterpret the first few times they see it
Uh-huh.
because it's not friendly, because you can't do, so you're like, what do I do? It's like nothing, like this is it, like that you're
So
done.
that
This,
so that's the final answer.
yes,
So then I'd write x equals and then just write both of those.
yes,
Okay, I kind of like the non-friendlies in a way. It's a little bit less work.
yes, true, true, but it doesn't, you're like, wait, I got to do something. It's like, nope.
Yeah. So there would never actually be a way to really solve those, even if you wanted to.
So you're used to getting a nice number, a
Yeah.
composite number, and you just don't get that here. You get a irrational, ugly thing.
Unfinished looking thing.
Yeah, yeah, exactly.
All right. So I have a question. Like, I'm not saying this is like how can I like trick you into making me solve it or anything, but so what if we were to solve it like that, like not actually involved with this, and like I'm not like training myself to like do it like this or anything. But like would you divide both sides by two,
You
or
you
would
you
you
you have solved it, and
all
what
right.
you're not liking. So I was working with on a in a totally different problem, totally different subject, completely unrelated problem, and the
Uh-huh.
answer was square root of 2 minus 1. Okay, that was truly the answer.
Hmm.
Okay, it represented the area between two curves like this, and like, believe it or not, that's the area. And like, what you want is, you want this to be like 3 or
Yeah.
1, or but what can be true is that it could be the square root of 2 minus 1. Okay, and you actually already deal with problems like this in your life.
Um,
Like if you took an inventory of like everything in your fridge, you have 2 cans, plus, one milk jug, cart, whatever,
uh-huh.
and you're okay with that, but somehow you're not okay with this because you want it to be something that it can't be.
Okay, that now that you said it like that, it's almost like funny in a way that I want to like solve it when it's like that.
But you have, though, like what you're not believing is, like, yet, and you will, is that like you've solved it. It is this thing.
Yeah.
It's just that this thing on the right isn't meaningful. It just
Uh-huh.
doesn't mean anything to you. You're like, I don't know what that is, because you're used to, like, well, like, what is the number? What is
Yeah, what's like that like one singular thing?
yes, yes. And the problem is,
Okay.
you can't write that singular thing, because let's say the singular thing is like 1.234 1, 0, 2, 5, 9, 8, 1, 4, 3, da 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 da. Like you can't write it out, because that's what it is. It ends up being irrational, which means it goes on forever.
Uh-huh. Okay. All right.
Now,
Thanks for explaining it with like the two
now,
cans.
no,
Like that
no,
was
no. Okay, now a math example that we're gonna finish this, but let me finish this thought with you.
yeah.
You have or will take a geometry course, and you have already studied the area for a circle, and you're not going to like this, but the ratio of every single circle in the world is the circumference divided by the diameter, and this is always this thing right here.
All
The
right.
ratio of the circumference to the diameter of every circle ever is pi. And what is pi? It is pi.
It is pi.
It is pi. It has a decimal representation which goes on forever. So why do we write pi? Because we don't want to write the decimal uh, representation that goes on forever. But you already know this. Like, you'll get a circle with a circumference. Like, if you take, well, baking is a good example, but these things, the circumference and the diameter, if you divide them, you always get pi. Always, 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 always. And you want it to be something else, but it is pi. So if we don't know what to call something, we make up a symbol, like this case, pi, and we accept it. We move on. We say that this is the representation of it. So in your problems, you're going to see a lot of answers like this, where it's the square root of 37. Just that's the way it is. Sorry.
Yeah.
Like that's kind of it.
All right. Well,
Okay, let's look at D, if you're okay with that.
yeah.
Oops, this doesn't look great. So it's x squared plus 8x equals 2. And your choices are, we went through this before, the GCF, which that does not apply. The other one is the square root property, and that does not apply. So then, but based on what I was telling you before, like, what does that like tell you? Because that's even, what does that kind of lend itself to?
Um. You can. It's might be friendly. No.
Completing the square.
Completing the square.
Completing the square.
So would I subtract 2 over?
Well, yeah, well, maybe, but like we could go down this list, but like, I made this note up here. I know we talked about a lot of things, but when that middle term is an odd number, you don't complete the square generally because it's kind of weird.
Right.
Okay, but when it's even like this,
You can
you
complete the
can.
square.
Okay. Now we've done a bunch of completing the square, so let's not do that. But the point is that you could use completing the square here, or let's use the quadratic formula. Let's give you another example of that.
So this is a good 2-in-1 type problem.
Yes, you could do it either way. And you might note that, like, you might say, oh, I can use the quadratic formula, or I can complete the square. Let me look and see, are there any other ones that I can, like, so that you know which one you're supposed to do on the exam. Because you don't need to do both. You would just choose the one that's easier or the one that like you have to do
Yeah.
on this.
Your closest given.
So for quadratic formula, it has to be in this form: ax squared plus bx plus c equals 0, which means there's a 0 on the right hand side. Is there a 0 on the right hand side?
Yes.
It looks like it's 2. See how there's a 2 there on the right hand side?
Oh, my bad.
So we want to subtract 2 from both sides to get all the numbers on all the terms on one side of the equation. So to use quadratic formula, you have to get everything on one side of the equation. You don't have extra stuff on the right. So what does A equal? What does B equal? And what does C equal?
A equals 1, B equals 8, and C equals -2.
Perfect. Okay, and now we're going to write out the quadratic formula. Opposite of B, plus or minus the square root of B squared minus 4AC all over 2A. And now we're going to substitute in the numbers for each one. I'll let you get caught up here, but that, you write the formula and then you sub in. That's just the most common way to do this.
All right, so you'll have x equals -8 plus minus. Oh, wait, am I supposed to write this myself?
No, I will,
Oh, my
Garrett.
bad.
There, yeah. Well, we'll do another one where you have to do this on your own, but it's 8
So
squared
8
minus
squared
4.
minus 4 times 1 times -2
Yep.
over 2 times 1. So then that'll have -8 plus -64 minus plus 8. So then that's 72 over 2.
Over 2, yeah.
And then
So to do this,
72, I don't think that's a friendly.
it does not work out nice. It does reduce. So remember that question I said, hey, go into instructor and ask. This does reduce. So you might consider that. We don't need to deal with it right here, but
Oh,
that is
I'll write
important.
that down as like a little reminder on my phone.
Yeah. But here you can actually divide the 8 by 2 because they're okay. They're like things. But on the right here, you cannot. Really, I should draw this division fraction bar bigger so you can see that it's not inside there.
So, okay, wait. So if that's square root of 72 over 2, that could be like 36, right?
You cannot divide what's inside the
Right,
square.
because it's like the wooden shovel in this little.
Yes, yes, it was a great example. It really is like that. You just can't do it. Doesn't work. Don't even try.
All right. And then x equals -4 plus minus.
Yeah, so I was really bad about this as a student, and I'm probably worse now. Is I actually stopped carrying through certain things,
Mhm.
but you really need to carry through x equals x equals x equals.
All right, cool. Yeah, I don't know. I do that too when I'm like really familiar with something.
Yeah, it's okay until you're getting a grade on it, and then
Yeah.
okay, let's look at B. Um, B is, I believe B is a factoring guess and check. We're not going to do it that way, but that is there. One of the giveaways is this 5 in front. If there's a
Mhm.
number in front, it's probably a factoring guess and check.
So if there's a number in front of x,
Yes,
all right, number in front,
of x squared, not x squared.
in front of x squared will commonly be guess and check.
Yes.
All right, noted.
Okay, so A is 5, B is -2, and C is -3 for quadratic formula. I believe this one works out nicely, meaning that square root is friendly. So I'd like you to try working this one out on your own, please, and see how far you get through it. It is totally doable, but I'd like you to try and just check back with me in a couple minutes and see how you're doing on this one.
All right, sounds good. Wait, so for guess and check is I'm gonna have two different
No,
parentheses.
we're gonna use quadratic formula.
Okay, my bad.
Yes,
Okay, never mind, never
that's
mind.
why I want you to try some here, because yeah, it's like the last one, slightly different, but give it a try.
All right, will do. And I can also write the quadratic formula out of memory now. I just
Oh,
found out.
oh,
So
great.
good thing going. Two. All right, I got it.
Okay, I'm gonna work it out here just in case you want to see, to compare, not just in case you want to see, to compare your work so that you can check your steps. So x equals 2 minus a -2 is 2, plus or minus. Now this is important here. I don't know if you do this. Whenever b is negative, I put it in parentheses, and that helps to avoid any weirdnesses with like
Confusion with like negative signs.
yeah, negatives and squaring. All over 2 times 5. Okay. So yeah, did you go beyond this? I'm hoping you did, but did you go beyond this?
Um, I did go beyond that.
Okay, perfect. So this is 2 plus or minus. This is 4. 4 times 5 times 3. Okay, that's 60. I'm sorry, 4, not 2. 4. Oh no, I'm sorry. 4 plus 60 because the negatives change to a positive over 10. So this is 2 plus or minus the square root of 64. That's good. That's friendly.
Oh, and then that square root of 64 is 8.
So this is 2 plus or minus 8 over 10. Now you were asking me about this earlier. Yes, there's implied parentheses. Okay, and that means like, yeah, you need to do that first. 2 plus 8 over 10, 2 minus 8 over 10. So this
10
is
over 10. So would I write that as 1? All right. And
yes.
then minus 6 over 10 minus 3/5.
Yes, that's your final answer.
X equals 1 and negative 3/5.
So the 3 problems we did from your your assignment here, A, B, and D, they can all be done by quadratic formula, but it wasn't designed that way. Like I believe A was the one that you were only supposed to do the quadratic formula on.
Yeah.
B, like I mentioned, could be factoring, guess, and check. And then D was completing the square. So let's look at C and E, and I'll try to give you like, here's why you would use the certain method for that. But really good though, really good that you're able to do that on your own. You'll probably have more opportunities to practice that in in the coming days, weeks before your test. Okay, so how many letters do you see?
I see one letter.
One letter. So that is generally an indicator of using the square root property.
So then square root property because okay, so wait, so
we're gonna do it, but I want you to go ahead.
This would not be guess and check because it's 5 and then parentheses.
It's more because there's only one letter. Like you've got the piece of paper in front of you. How many letters do you see in letter A? Well, I'm sorry. How many letters do you see in x squared plus 7x plus 3?
7x plus 2.
2, right? Like, let me go. And how many do you see in B? 1, 2.
1,
and,
2.
And how many? Yeah, we already did that. 1, 2. So the point is that if you have one letter, because like if you look at letter E, how many letters are in that? 2x squared equals 9x.
2.
So this is the only one that has 1. This is square root property.
Square root property.
So really quickly here, I'm going to just show you, you add 40 to both sides. You divide by 5.
Excellent.
And then this is where you use the square root property.
Square root. And then there is no square root of 8, right?
It is not friendly, so it doesn't work out.
So then that would be x minus 1.
Oh, yeah, you actually, I think, had the right answer on there. Let me jump to E, because this is really important, because this identification is important. This is GCF because only terms with X. This has an X in it, and this has an X in it.
So
that's how you know it's GCF. If you look at every other one on this page, there is a single number without an X.
And this is the only one with all numbers having X.
Yes. So I know your curriculum pretty well because I've helped students a long time in your school, and they give the same stuff every year. You want to find the GCF one first, and then you want to find the square root property one first. Second, and that's how you attack this exam. You find the ones that are absolutely positively that approach.
Okay.
Yes.
I'll get some tips here now too.
Yeah. Well, goal is to get you to do as best as you can, and you're truly learning here. But why not? Why not get a few tips and hints along the way?
Tips and tricks.
Yeah. All right, Zach. Well, great lesson today. As always, I really enjoy working with you. You're a great student to work with. So
All right,
appreciate it.
thank you,
I'll
Matthew.
send you the notes and the screen recording here shortly, and I'll see you next time.
All right, see you next week. See you, Matthew.
Have a great
Thank
night.
you.
Bye now. You're welcome. Bye now.